Welcome to The Explainer. Hey, Python devs, you're about to get a brand new superpower, teaching machines how to read. We're going to walk through everything you need to know about natural language processing, taking messy, everyday language and turning it into a real, working model. Let's do it.
So, have you ever stopped to think about how your email app just knows what's spam? Or how your phone's assistant actually gets what you're saying? It's not magic, I promise. The secret sauce is something called natural language processing, or NLP for short. It's this really cool corner of AI where we give computers the power to understand us. You know, human language.
All right, let's really get into it. What we're doing here, at its heart, is building a bridge between how we talk and how computers think. And trust me, it's a huge challenge. Teaching a machine to really understand what we mean, yeah, it's way, way harder than you might think.
And that leads us right to our first major roadblock. See, computers love neat, tidy spreadsheets. Everything's in a box. But human language? Oh man, it's a total opposite. It's messy, it's all over the place, and it's absolutely soaked in context that we just get, automatically. Okay, so here's the key thing to remember. To a computer, a word is just a bunch of letters. It has no clue that the word bank could be where you put your money or the side of a river. And it definitely doesn't pick up on sarcasm when you say, "Great, another meeting." So before a machine can even begin to understand us, we have to clean up all that mess and get the text into a standard format it can work with.
So this is where we get to the most important first step of pretty much any NLP project. It's called text preprocessing. This is our cleanup phase where we take that messy human speak and turn it into something clean and structured that a machine can finally start to process.
I love this analogy. Think of it like you're about to cook a big meal. You wouldn't just throw everything in a pot, right? No way. You've got to wash the veggies, chop the onions, measure out your spices. That's exactly what preprocessing is. It's our digital kitchen prep work.
And this pipeline here? This is basically our roadmap. It shows the whole journey. We start with just a raw string of text. Then we break it apart, we clean it, we normalize it, and at the very end, we turn it into what a computer actually understands. A list of numbers, a numerical vector. That's the end goal.
And look at this. This is the perfect before and after. We go from something like, wow, NLP is amazing, with all the punctuation and weird capitalization, and we boil it down to this clean, simple list of the words that actually matter. Just wow, NLP, amazing, nice and clean.
Okay, so how do we get there? Let's break down these key steps because each one is super important. First, lowercasing, right? So an NLP and NLP become the same thing. Easy. Then tokenization. That's just a fancy word for splitting a sentence into individual words, or tokens. After that, we do stop word removal. We toss out all the junk words like is, and, the, that don't add much meaning. And finally, stemming or lemmatization. This is where we get words down to their root form. It really helps simplify things.
All right, so now our text is sparkling clean, standardized. Awesome. But we've got another big problem. Remember? Computers don't speak English. They speak math. They need numbers. So now we've got to figure out how to turn our clean words into a bunch of numbers.
Well, the easiest way to do this is a method with a great name, bag of words. And it's pretty much what it sounds like. You just imagine throwing all the words from a sentence into a bag, shaking it up, and then just counting them. The grammar, the order, none of that matters. We're just counting.
Let's look at a quick example. First, we make a list of every unique word we have, right? Our vocabulary. In this case, it's I, love, NLP, and Python. Then we just go sentence by sentence. Does I love NLP have an I? Yep, that's a 1. A love? Yep, 1. NLP? 1. Python? Nope, so that's a 0. See? It's literally just counting. Super simple, but it's got a big flaw.
And here's the problem. Bag of words thinks every word is equally important. So a super common word like the is going to get a really high score. But does it actually tell you what the text is about? Not really. It's just noise. We need a smarter way to figure out which words actually matter.
And that's where this other, much smarter method comes in. It's called TF-IDF. Now, don't let the long name scare you. The basic idea is that it doesn't just count words. It calculates a special score that tells you how important a word is to one particular document, especially when you compare it to a whole bunch of other documents.
Okay, so here's the magic trick. TF-IDF rewards words that show up a lot in one document, but are rare everywhere else. Think about it. This is how it automatically spots the important keywords. A word like Python might be all over a programming article, but not in a cooking recipe. so TF-IDF gives it a high score. It's just so much better at finding the words that really define what a piece of text is about.
Okay, that's enough theory for now, right? Let's get our hands dirty and actually code something. We're going to build a super simple sentiment classifier using Python and the awesome scikit-learn library just to see all these pieces click together.
First things first, every model needs data. So here's our sample set. We've got a list of simple sentences and then a matching list of labels, either positive or negative. This is what we're going to train our model on.
Okay, now check this out. With scikit-learn, this is crazy easy. We just use this thing called count vectorizer. It does all that pre-processing work for us and turns our text into those bag of words vectors we talked about. Boom, done. Then we feed that data into a simple classifier, in this case one called multinomial naive Bayes, and tell it to learn the patterns.
And here's the fun part, the payoff. We can take a totally new sentence, something the model has never seen, like amazing quality and great value. We give it to our model, it does its thing, and bam, it predicts positive. It works.
And that's it. Look at that. With just a few lines of Python code, we've just taught a machine to understand human sentiment. I mean, how cool is that? It really shows you how easy it is to just get started with this stuff.
So you've just seen the whole pipeline from start to finish, from a messy sentence all the way to a working model. But you know, the absolute best way to make this stuff really sink in is to try it out for yourself. So, I've got a few little challenges for you here. My advice? Try doing them by hand, without code at first. It'll really help you get a feel for what the computer is doing behind the scenes. You'll build up a way better intuition for how it all works, I promise.
So there you have it. You now have the basic toolkit to do some really powerful things. You can analyze customer reviews, you can sort news articles automatically, you could even build a spam filter from scratch. The fundamental pieces are all the same. So the only question left is, what are you going to teach a machine to read first?